looks like the one at the sides of the parabolas on the
Kevin, don't try to save everybody from doing this. I appreciate that, though. So, right, y equals x cubed. Kevin's like, I'm just trying to help. And do this. And graph. Go.
What chapter is this from?
Section 12.1.
Okay.
Yeah. So do this. Finish that table out, and then graph. And then let me know if you just came in to get your test back. Coming up here. Sure. Did I put your? Yeah. Okay. So it was curved a little bit. So what's negative 2 cubed? Negative 8. What's negative 1 cubed? Negative 1. I got all my dead markers to pick from.
It's Prime Day.
It's the marking dead. Huh? Sorry? Oh yeah, thank you. Negative 1 cubed, sorry?
Negative 1.
Negative 1. 0 cubed.
0.
Amazing. 1 cubed. 2 cubed. So it looks like this, and then I got, it goes we. Does that have an inverse? Yes, because it horizontal line test. So as long as it's like x cubed, or it's just moved up or moved down, if it's only moved up or moved down like that, then it's got an inverse. I like it. Okay. That should help you out with that section if you haven't finished that section yet. Okay, cool. Anything else from homework stuff? Last time we did 12.5, 12.6, and I made, what was it? 12.7? I think I made 12.7 extra credit. Yes.
But you haven't.
No, I guess not.
I have a
No.
question on the test.
Yes.
For number 4, it said you have 200 feet of fencing. What's the dimensions and
Yeah.
what is the max area?
Yeah.
So the max area is 120 squared.
No.
How do you find max area though?
So, I mean, if I got, if I had 100 feet of fencing, and I wanted to construct a shape out of it, there's no way that max area could be 100 squared, because it can't be 100 by 100, because I only got 100 feet, right? So if it was a real square I was making, then that would be 50 by 50, but it's not a square I'm making. I took one side away, made another little thing there.
Yeah.
We're obviously going to put this up against something maybe, right? So then what do you call each of these?
X or Y.
Axis.
X or Y, doesn't matter. And what's this guy?
Y.
That's crazy. So they tell you so many feet to construct all these walls, and then they ask you about the area. You got to solve what they tell you for a letter and plug it in what they ask you.
Well, yeah, I solved it correctly. I just couldn't figure out how to get the max area.
So you got X and Y, right?
Yeah. I got
multiply
X and Y
those. Right. That's the formula, right? How you find the area?
So it's 120?
X times Y.
3.
That's what I mean. So area is X and Y, so it would have been 120.
Oh, 1,200.
Oh,
Yeah.
Okay.
It's kind of a coincidence. It's almost the same number. There's no way.
That's where it screwed me up, because I was like, how can that be the same answer? And that's why, oh my goodness.
To be honest, it could possibly be, but more likely it wouldn't be a max, but still you could make it so it's that. You can have the perimeter equal the area, easy, but that wouldn't probably be the max area. Yeah.
Gotcha.
Yeah.
Can we go to 12.2? I kind of forgot how to do the first part of that as well. Which it says graph and kind
For which one?
12.2, number 13.
Number, I'm sorry?
Any problems in the first set, 11 through 40?
Make an XY table for 11 through 40, yeah. Right?
Is that what it wants us to do?
Yeah, makes an XY table. You shouldn't need that many points. because you should know the shape of the function, right? All right. For this class, it's important, but especially if you're going into pre-calculus, the more you know the shapes of things, the quicker everything will be. So I know that x squared stuff is like this. Yay. I know that x cubed stuff is like this. I call it cubish. It looks like a parabola where half of it fell out. Right? It's like, yay. A colleague of mine calls it the giraffe graph, because if you put a leg here, it looks like a giraffe. And I was joking. I'm like, it's bleeding. You lost a leg. It's going to fall over. That doesn't seem like a nice thing. Even though I teach like kill everything math, but that always seemed a little evil to me. It's a giraffe graph. It lost its front leg. It's about to fall over, but there it is. I'm like, all right, whatever gets people through. Let's talk about you, Corey. Is that cool? Is that all right? What's an exponential look like? Can you draw it in the air? Exponential. A to the x. Swoosh. Yeah. Right? Looks like some company's logo. Swoosh. All right. All right. And a logarithm. There you go. A log looks like this. If an exponential looks like this, a log's got to be its mirror image, remember? Whee! I can do that at the same time almost. Okay. All right, cool. All right. Anything else from homework stuff? Who else didn't get their test back yet? Come on up here.
Did you already go over test questions?
I am right now. Bless you. Yeah. Yeah, they were curved a little bit there. By the way, I don't think I said this earlier, but the average was a 71.3 after curving. 4 A's, 6 B's, 4 C's, 7 D's, 5 F's. I've got the averages figured out. I just didn't have time to do anything with them.
That was the best test average.
That's after the curve. But yeah.
Still, it was the best test average also.
I'm not jumping up and down. Sure, yes. Okay. Anything else from homework before we get back into new stuff? All right, Will. Will's all like, I'm trying. Just I like there's a cloud for every silver lining. Yeah. Anything else? Nothing? Okay. All right. I'm so happy more of you are here. That makes things work better. Okay, so last time, let's do a quick review of what we did last time. Could somebody figure out the vertex for this guy here? Vertex and x-intercept. Let's see if we can get those. So the thing about everything we did remains the same. It's just that the variables have switched. So negative b over 2a is going to tell you the value of what? Y. Because that's the main variable. That's what we call the independent variable. Oh yeah, I've got to print that out. All right, let's see. What do you guys get for the y piece? Yeah, it'd be negative 16 over twice 4. That's 2. That's the y piece. How to get the x piece? Yeah, x depends on y. Once I know y, I can get x. So x would be 4 times 4, 16, minus 32 is negative 16, plus 11 is?
Negative 5.
Negative 5. It's not too bad. X-intercept is the easy one to get now.
11, 0.
Yeah, because when I make y 0, I can see x is 11. So I'm trying to graph this.
How did you find the x-intercept again?
How do you always find the x-intercept? Make y 0. If you had an equation with 18 letters in it, how would you find the w-intercept? You would make all the other letters 0. What would that mean? Who gives a shit? How do you find intercept always? Make the other letters 0. And for us, make the other letter 0, because we only deal with 2 at a time, thank God. You don't want to think about it. X-intercept make y 0. Y-intercept make x 0. That would be the one that would suck here. What would you have to do to figure that out if I wanted the y-intercept? Y-intercept. What would you have to use to figure out the y-intercepts? If you make this 0, what's it look like you would use?
Factoring?
You would try factoring and quickly give up because it's not going to work. Quadratic, yeah. And again, for these guys, x and y have switched. Normally when you did quadratic, you figured out what x was. Here, when you do quadratic, you're going to figure out what y is.
And can we use filling the square?
You could use completing a square if you're feeling a little crazy. But why is that a little crazy? Quadratic formula is how related to completing the square? Quadratic formula is a shortcut to complete the square. So that's why on some of your tests I said, whoa, people complete a square and a couple problems. I'm like, why wouldn't you just go ahead and use negative b plus or minus? And then you tell me, because I forgot it. I'm like, all right, it's good you did something. So the graph, this is not as bad as it might seem. Negative 5, 2. Negative 5, 2.
How do you get a negative 5, please?
Are you cool with us getting the y?
Yes.
Beautiful. Well, the minute you know y, you know x. You just got to plug it back in.
Oh.
Yeah. There's negative 5, 2. Is that cool? That's the vertex. And then I can also plot 11, 0. And then where is there a mirror image point? 1, 2.
1, 2.
1, 2. So I'll be right here. Plop. And then you go, all right. Make that big. Real quick, you want to be nice to yourself about scale. If I would have been even nicer to myself, I would have blown the scale up a little bit. See how tight that is? I would have maybe blown it up a little bit, you know? Maybe made these halves or something. Your scale can be, as long as it's consistent on an axis, they can be totally different from this axis to this axis, and you just want to make it so you can find the points easy. So be nice to yourself about scale. All right, hello, yeah. Yes?
How'd you find the other point? You found 11, 0, and you found...
What's this line I drew here? What's this dotted line? What's that? Axis of symmetry. So all the points are symmetric around that line. So if there's one here, there has to be a mirror image there. That's 2 away from the line, so that's 2 away from the line on the other side.
Okay.
Just like that dude in the mirror you look at is the same distance away from the mirror as you are on the other side.
And how do you find the axis of symmetry?
What's the axis of symmetry you have to go through? What's the point that it definitely has to go through? What's the middle point? Vertex. Yeah. In this case, what's the equation for the axis of symmetry? All I did here was I drew it in. I just drew the vertex, drew it in. That's easy.
Yeah.
What's the equation for it?
Y
equals 2.
2, not 3.
Yeah.
3.
I know. for up and down, it was x equals. Now that everything's turned around, it's going to be y equals. It's going to be a horizontal line. Okay, so everything is exactly the same work. It's just that everything that used to relate to x now relates to y and vice versa. Why? Because we switched it. That's why. Hopefully some of you guys realize this could have been the y-axis, could have been the x-axis from the beginning. It was semi-arbitrary why we picked it the way we did. That's really sort of what this is saying. All the work is the same. If you just switch over here, all the work's the same.
That's why on 1, on test 3, that's why it's x, because it's opening and down.
That's why it's... Oh, well, that's why the axis of symmetry is x?
Yeah.
Yes.
Yeah.
Because it's a vertical line, which is x equals. Okay, okay. So that's one. That's the first kind of thing we looked at in chapter 13 was sideways parabolas. And then we looked at circles. Circles are fantastic. Gotta love the shit out of circles. If you don't, you're really gonna hate today. Let's hope nobody's out there saying, I hate every day of this class. It makes me sad. So real quick, circles. So if I have a circle in this form, what can you tell me? No.
No, center.
Center?
And the radius.
What would the center be? Radius, I'll go out on a limb and say it's R. What's the center of this circle? HK. They love those letters H and K. I still have to research why that is, to be honest. I'm sure there's somewhere in time there was Horace and Kevin. You know, like,
Move it. Let's make it HK.
Adventures of Horace and Kevin. So if I had this circle, what would its center be and its radius? What's the center of that circle? 1, -5. Beautiful. See how you switch the signs? Because it's minus h. So h is 1. Minus -5 would be +5. That's why it's -5. You just change the signs. When it's in with the letter, you change the signs. Because the numbers I put in for y have to be 5 less than they used to, because the first thing I do is add 5 to them. That's why it's the opposite. What's the radius? 10. 10. Because that's r squared, so radius is square root of that. This really is just Pythagorean theorem. It's crazy. It's the part that I think students don't realize, how we put equations of things together. We use the basic idea of what creates them, and then that should make the equation. That makes sense. Whatever makes it visually should create the equation. They go together. Okay, so that brings us to now.
That's the formula on the left.
This guy right here is the main formula for a circle. Now remember, we did problems like this. We're not going to do this right now, but I don't know why that's the next.
Yes, because basically splitting the equation in half, right?
Yeah, what method would I have to use on this to make it look like this? Complete the square. How do I know it's a circle? This is what we're going to get into today. Two things. There's a plus, right?
And the square.
And the x squared and the y squared have the same coefficients.
Isn't it if it's minus, it's something else? Is it
A pergola, yeah. So think about it like this. A circle kind of comes together. An ellipse comes together also. It just has different coefficients, so it goes differently in the x and y direction. That's why it's longer in one direction than the other. A hyperbola doesn't come together. It goes apart, so it's the exact opposite operation. It's minus. So let me see if you guys get this. If I said, this is a little bit early for this, but oh well. If I said two positive numbers add to be 12. Two positive numbers add to be 12. Could these be anything they want to be? Could these be anything they wanted to be? So if x wanted to be 50, it could be 50?
As long
Why couldn't it be 50? What did I say is true about these two numbers? I said that they are both positive. They're both positive. If this was 50, what's the only thing this could be to make it 12?
Negative.
Negative, blah, blah, blah. Who cares? So that's impossible. So this is contained. There's a plus in between two positive things. It's contained. I love this idea. I wish to God everybody would get this. That's why the picture is contained. What if I said two positive numbers subtract to be 12? Could this be 50? Oh, hell yes. Right? Because then this could be 38. That's positive. So when you subtract them, you get 12. That's uncontained. That can go forever. Why are you yelling, Jeff? I don't know. But this one, can they be as close together as they want to be? Yeah, they can be the same number, can't they? 6 plus 6. So they can be close. This one, what's the closest they can get? 12. They don't get closer than that. They don't get very close, and then they go forever. It's uncontained. I love that idea of why a plus means circle or ellipse, contained, and a minus here means hyperbola, uncontained. You can go forever in some odd direction. Okay, so let's come back.
Has to be in the middle?
Yes. So if that's a plus there, it is either a circle or an ellipse. An ellipse would have a different number here. The coefficients would be different. Why does that make sense? What's the basic idea? The difference between a circle and an ellipse. An ellipse is longer in one direction than the other, meaning the x and the y's have to have different things happening to them. So let's look at ellipses. Ellipses. All right. So let me start with what I just said and then put it in a better form. So here's an example of an ellipse. Two things. It's plus, so it's one of the contained is either circle or an ellipse. And of course, why is this an ellipse? Coefficients are different. I like it. It's actually going to go further. Can anyone tell which direction it's going to go further in? All right, now let me ask you this instead. All right, you ready? What's the biggest x squared could be? All right, this is a really weird question, I know, but they're supposed to add to be 36, right? The minute y is not 0, the minute y is anything that's not 0, this has got to be bigger, right? Because I'm adding something. I mean, this has got to be, sorry, it's going to be smaller. Because I'm adding something to it to make 36. So the biggest x squared could be is when y squared is 0. So if y squared is 0, what's x squared? Oh, gosh. Where'd the good one go? Well, so y squared is 0. You're not much better. What's x squared got to be? X squared. X squared is going to be 4. I like it. And then it would be 2, negative 2. Now, I do the same thing for the y. If x squared is 0. Then y squared would equal what? 9. So that would be plus or minus 3. So this is going to go out 2, and that's going to go out 3. Let me stop right there. So this is going to be almost too nice to believe, but I've just found the most important points here. So on the x, it goes up to 2 and down to negative 2. When y is 0, right? When y is 0, that's what it does. And when x is 0, it goes up to 3 and down to negative 3. So there's my ellipse. We. Well, when I see my art critics out there, that is hardly an ellipse. All right, but, all right. Again, it's contained. So what makes this the biggest is when this is the smallest. Since it's positive, the smallest it could be is 0. So I find my extreme values. Now there's got to be, this is not the best form for this ellipse. There's got to be a form that leads me directly to those numbers. So watch this. If I divide everything by 36 in that equation. Try it. Just divide both sides by 36 and reduce. So here I get 4. Here I get 9. And here I get 1. So look at this. What's with the x? 4. So in the x direction, I'm going to go out 2. That's what we call this a squared. What's with the y? 9. What's the square root of 3? So I'm going to go out 3 in the y direction. Please understand how incredibly awesome that shit is. If you make it equal to 1, the numbers with the variables are the square of how far you go in that direction. Why does that make sense? Because if this is 0, what's this got to be? 1. And what makes it 1 is when x squared equals 4. So instead of doing all that shit, just put it in this form and then look. That's 4, so what's if a squared is 4, what's a going to be? Plus or minus 2. So it's going to go up 2, down 2. In which direction? The x direction, because that's what the number was with. Holy shit. That's awesome. Let ellipses be easy as all hell. All right, let's do another one. Let's do one, immediately put it in the right form and do it. Here we go. So if I have, what you got, Jeff? Oh, man. 16x squared plus, what's going to work nice? I don't know. Yeah, sure. 9y squared equals 144. No, let's make it, choose something, dude. Ah, screw it. I guess that'll work. That's fine. So what's the first thing I need to do? Yeah, divide by 144. So then you get x squared over 9 plus y squared over 16 equals 1. So how far do you go in the x direction? No. 3 up, 3 down. A squared is 9, so a is plus or minus 3. B squared is 16.
Plus or minus 4.
Plus or minus 4. And then you just do that. You go up to 3, negative 3, 4, negative 4, connect. Next.
Wait, can you say that again?
Sure. So what number is this with? I mean, what variable is this with? X. So that's going to be how far I go in the x direction. That's going to be how far I go in the y direction. Do that. Connect them. Done. Yes?
Why do you use A and B as variables?
A and B are parameters here. A and B. Because what could be down here? Why was this a 9? Just because I picked a 16 there and a 144 there. What could it be? Anything. All right, so the general form, let's graph this real quick and then I'll put the general form of a ellipse up here. So this would be very, 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 very easy. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 4. Dot, 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 circle. Not circle. Ellipse. Okay.
You started at 0, right?
Yes, good point. Why did I start at 0? Because these have not been shifted.
How would it look shifted?
Just like a circle.
How would it look shifted in the
If I wanted to shift it back 1, there would be a x plus 1 here instead of x. Same thing as always. Once you learn shifts, you've learned shifts. Period. It does the same thing to every. If I see an x plus 1 somewhere, it's going to move the whole thing back 1. So centered at 0, 0, here's what it looks like for an ellipse. Centered at 0, 0 would look like x squared over a squared plus y squared over b squared equals 1. If it's centered at hk, it'll look like this: x minus h squared over a squared plus y minus k squared over b squared equals 1. So the only thing you have to do if it's not centered at the origin is you put a little circle at the center and you do this counting from there. You gotta love ellipses. You just have to. You just have to. If you don't, you refer to my statement. You have to. So he was like, I don't care what you say, Joe, I don't. All right, let's try one more of these.
Is that the equation for ellipses on the right?
Totally, yes. General form of ellipses. Let's see. First thing is it exactly in the right form? There's one thing I could do to make it look more like that form so I don't miss something. What can I include here that's understood to be there? Yeah. There. Now it totally looks like that form. Yeah.
Aren't there like 2 cops cars outside here?
Huh?
Aren't there 2 cop cars outside?
They're busy.
Drinking coffee.
Yes, somebody has to. Spend all the money for the car. He's got to be able to do that. Dipshit. Let's see. So where's the center?
2, -2.
Negative 2,
1.
1. There always is a reaction to what's in there. That's why it's the opposite. If I'm adding 2 to it, it could be 2 less than it used to be. Down 2. Or, back 2. If I'm subtracting 1 away from all my y's could be 1 bigger than they used to be. So that's why the center is going to be negative 2, 1. X direction, how far out do I go? No, X direction.
Up 2, down 2?
Yes, I go left 2, right 2, yes. So plus or minus 2, is that cool? And then Y direction, how far out do I go? Plus or minus 1. So, center's at, it's the other way around, Jeff. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. Let me see. Negative 2, 1. Go gather. That's the center. And then from that center, in the X direction, I go over 2, back 2, and then from that center, I go up 1, down 1. What happened? Y direction, what did we say we were going to do? Go up and down 1. So then I find the center, go up and down 1.
Oh, yeah.
I don't understand. X direction, up, left and right 2. Find the center, left and right 2. How do you check this? What's the matter? Mama. No, I always see Stewie when I do that. How do I check this? Anybody? I kind of want somebody to say, put it in your graphing calculator, and then I'll ask you, how the shit do you put this in your graphing calculator? Nah. That will take a lot of work. Because what's the button you push to put something into a graphing calculator?
Y equals.
Ah, shit, you have to solve this for Y. So if you want to do that, sure. What's a better way to check it? Didn't I just go through a really easy point here? What point is this? What point is this?
-2.
Negative 2, 0. So if I put a -2 in, make sure that works, right? -2 plus 2 is 0. So that whole thing is 0. So then that's got to equal 1. Square root both sides. Y minus 1 equals 1. Y equals 2. What did I do wrong there?
No, I thought -1.
Negative one.
-1. Okay, thank you. Yeah. So you can always check. You can take a point that you went through and make sure it works in the equation.
How'd you find the other points? I understand how you found center, but how'd you find the ones surrounding it?
Are you cool with this step right here?
Yeah.
Yes? You sure? And that was just because of these, the square root of that, the square root of that. So I find the center, and I go in the x direction, 2, 2, and in the y direction, 1, 1.
Oh, okay.
Yep.
One more time, can you...
Yeah, so again, let me be better. So this is -2, 0, right?
No, not that part.
Which part?
The form for ellipse was the x and the y had different coefficients, right?
Yes.
And how'd you get those on the bottom real quick?
Divided by, well, I mean, this one just started off in this form. But this would have been x plus 2 squared plus 4, y minus 1 squared equals 4, and I divide by 4. I could do that, or it could just be given to me like this. And when would this equation become the equation of a circle? If what's true? If A and B are equal, you get a circle. It makes sense. A circle is just a special ellipse. That's it. A circle is an ellipse that's symmetric in all directions. Just like a square is a special rectangle. Right? A square is a rectangle where all the sides are the same length. Please tell me you know this.
I thought the square was a square.
Totally is. Right? A dog is a dog, but it's also a mammal. See, I mean, there's... Right? So a square is a rectangle. And then people look at me like I'm insane, but what's a rectangle? The sides are parallel. So can't a square be a rectangle? Of course it can. It's just a special rectangle. It's where all the side lengths are the same.
Can a rectangle be a square?
No. Does a mammal have to be a dog?
Exactly.
I'm gonna go home and tell my mom what I learned today. She's gonna be like, stupid.
All right, let me give you this here. Let me see. Where did it go? Here it is. I had a little problem on the top about circles.
So far in life.
Ignore that fire.
So far in life. Oh my god, it's not that funny. Shut up.
Secret reaction.
Okay.
Ellipses. Ellipses. On the back is some that's centered not at 0, 0, right? So why don't you guys try number 2 and number 4. So 2 on the front, 4 on the back.
So, big triangle. Downstairs or something.
Yeah, don't worry about the circle one at the top. Skip the circles. We already talked about circles. Start with ellipses. So number 2 at the bottom of the front, and number 4 in the middle of the back. Let me put the problems up here. Yeah. it a little bit there. Yeah.
What sections are going to be in the test?
It depends on how far we get in the third.
So what's the first section?
Chapter 1.
Okay.
I mean, remember we did a review of 1 through 6 to start with. Finals cumulative. So it couldn't be any. Like little fraction problems, order operations problems from chapter 1 and stuff. You have the practice final. I will give it to you in a little bit.
No. Yes.
Oh, well, I said 2 and 4.
So there is,
Oh.
there's no
Let me see.
plus here.
Oh, you're only supposed to go 2 up anyway.
I know, but
You're supposed to go 5 in the y direction. See that?
Oh,
Yeah.
gotcha,
Yeah.
Yeah, no, it's because center zero because there's nothing next
Yeah.
to it, so this one, that's definitely not gonna be. It'll be a zero.
disagree. So,
Oh, okay. So it's
this one.
Careful here. 4, 36 reduces to. Oh, I see. All right. X squared is a term. It goes over 36. 4y minus 3 squared, that whole thing is a term. It goes over 36, and you can reduce this. And of course, those numbers tell you how far to go out in those directions from the center. Yeah.
Would you, see, I don't,
the foods, whatever. I don't know.
Wait, what? Wait. No. All right. Guys, help me out here.
Yeah, I don't know.
On this side, how many terms are there? On this side, how many terms are there? 2. Right? How do you tell? Because there's only one plus sign. Terms are separated by plus and minus. So you divide each term by 36. There's no... Are there any x's running around? No. Are there any y's running around? No, they're all already captured. There's no completing the square that I have to do. So this will be... Why am I dividing by 36? Because this side's supposed to be 1. And what's so great about that form, I see the number that goes to the variable that tells me how far to go in that direction. That's why I put it in that form. It's the most useful form. So for this first one, what's the center?
0.
0, 0. How far do I go in the x direction?
Plus or minus 5?
How far do I go in the y direction?
Plus or
Plus or
minus
minus
15.
15.
I know your brain is balking. You're like, I must be mishearing him because it can't be that easy, because math is never that easy. And I say it's easier more often than you think. You just try to make it more than it is. So x direction 5, 1, 2, 3, 4, 5, pop. 1, 2, 3, 4, 5, pop. Y direction 2, 1, 2, pop. 1, 2, pop. I'm doing everything from origin because that's where the center is. You only do it from there if that's where the center is. You always go these steps from the center. And then you connect them as well as you can. Wee-haw! Woohoo! Yeah! Not too bad. All right. It's a football that was not used by the Patriots. Super Bowl a while back. Bunch of cheaters. All right, what do we get here? Now, what's the center for this one?
0, -3.
0,
Or 0, 3.
3. X direction, how far are you going to go?
Plus or minus 6.
Plus or minus 6. Y direction, how far are you going to go?
Plus or minus 3.
So you have a process that's built on the ideas that we discussed. The process is easy because the ideas were fully fleshed out. It's built on all these concepts. So don't feel like you're doing something wrong just because it feels too easy. So the center's... So center is 0, 3. Where'd you go, Jeff? You went the wrong way. 0, 3, pop. And in the x direction you go. Yeah. So I go up 6. I'm sorry, not up, but make this a center, Jeff. There you go, buddy. So I go over 6. 1, 2, 3, 4, 5, 6. And then I go back 6. 1, 2, 3, 4, 5, 6. Then I go, from the center I go up and down 3. So up 3, down 3. Oh my gosh, that's really horrible. He's got the bumps. Just came from the dentist. I don't know.
You got the center because it's -3 and it's compatibility.
Yeah, all my y's have to be 3 bigger than they did before because I'm subtracting 3 from them. So that's why it goes up 3. It's a reaction to that thing that's in there. How do I check this? What's the simplest point that it goes through from my graph? 0, 0. If I put a 0 in and a 0 in, that's 0. That's -3 squared is 9 divided by 9 is 1 to check. Yeah, I feel pretty good. At least that one point works, and it's really good evidence that the whole thing is good if one of your points works. Yes?
Is it ever going to come with? Is it ever going to come at us with a numerator that isn't squared?
If one of these was not squared, what does that mean?
That you have to.
If that wasn't squared,
It's not an ellipse.
not an ellipse, what is it? X, y squared. It's a parabola that opens left to right, right? If both of the variable stuff is squared, then it's a circle, ellipse, hyperbola, one of those. If only one of them is squared, then it's a parabola.
And then what if the bottom doesn't square out?
Then you got a gross amount to step by. Then you approximate with the decimal and you approximate the steps. Yeah. Like if it was 11 down here, that would kind of suck. Square root of 11 is about 3 point something, so you go 3 and then a little bit extra. Yeah. I'm going to try not to do that to you because it's more of an exercise in going
so
crazy.
How do we do that just in case it comes up?
That's how you do it. So, I mean, if it was 11, let's say this is 11 instead of 9. Then I would have went up and down square root of 11, which you put in the calculator and you approximate it. 3.2, whatever it is. And then instead of going just 3, I would have went 3, and a little more.
But still make it. Like
Yeah, of course. Just because the numbers would get gross doesn't change any of the concept. Right? Math didn't give a shit that you have square root of 11 somewhere. Right? The shape doesn't change. It's just that the steps I got to take are going to be a little bit worse. But you approximate it with a decimal, and we're doing it by hand. It doesn't have to be perfect. Okay, just in case the book throws it, or I don't think I threw that at you with the homework I'm going to give you. I guess you'll find out. All right, what else I want to say here? If you go into pre-calc, you guys will talk about something called foci. Focus, the focus of something. So we order around the sun in an elliptical fashion. The sun is not at the center of our orbit. The sun is at a focus of our orbit. So an ellipse has a center, and then it has these two foci. And the more circular it becomes, those foci go together until they become one. Aww. So circle, they're both in the middle. And the idea of a focus makes sense when you think a parabolic arch has a focus. And that would be where the light that comes in would all go to, which is what focus means. Right? So if you have a parabolic telescope, you put the little viewing station right here because that's where all the light's going to come in. So you can have a mirror telescope, a parabolic mirror telescope, and you have all the light coming in from up above, and then all focuses here. So that's where you put your little viewing station. So you can have this thing, and you can have this. You have to go up to it, and then you can sit in there, and you move the thing around, and you're like, oh, cool, and you're actually looking behind you, which is kind of neat. So they don't have to be lenses all the time. They could be mirror telescopes, right? And I think normally they have them in these hexagonal, and then they put them together piece by piece. It's kind of neat. Can't remember the one in Hawaii is like that. I don't remember. Okay, enough of that. Sorry. But that's just one of the uses of these things, and that's why it's called a focus. That's why they're called foci, because they are related to that idea. Okay. Let's see.